Okay, everyone, this is 5.1 continued, page 2 and 3. So what we're going to do, we're going to change from exponential form and vice versa. Okay, and go the other way. So the first thing you want to look at is when you have exponential form. Remember, it's going to be y equals b to the x. And I'm going to use 3 different colors so that I can kind of designate between the two and between the 3 things that's happening. Okay, so we're going to say, here's y, and it's considered the argument. Equals, and I'm going to do b, and then b is the base, and x is the exponent. Okay, and then when you convert that, if you have y equals b to the x, you can convert that or change to log form. So we have log, b is the base, y is the argument, equals the exponent. So again, here's your exponent, here's your base, y is the argument. Okay, so there's an arrow trick that you can use, but I don't use arrow tricks, so I'm not going to put it in here. I'll try to remember how to figure it out for somebody sometime, but if you need to or would like the trick, the reason I don't like to do trick is that usually when you go to do it for other things, when you go farther into applications of exponent functions and log functions, you want to make sure that you know the forms and what they mean more than anything. And I feel like if you just do without the trick for a while, then you'll get it. Okay. The thing that's always what you must know is that the bases always stay the same. Okay. The bases are the same, but the log is always equal to the exponent. What I always say is remember the log always equals the exponent. Okay, so based on that, what we're going to do is we're going to complete this chart, and we're going to change from exponential to logarithmic form and log back to exponential form based on where we're at. All right, so again, what we're going to do is we're going to have, if we're going to go to exponential log form, we have to have a log. Okay, we know this is the base, so that makes this the base. We know that this is the argument. Okay, so the argument goes here, and it always has to equal this exponent. Okay, the log always equals exponent. The log equals the exponent. Okay, the next one, our base is 10. So we can write log base 10. Okay, this is our argument. All right, oops. That's your base, and here's your exponent. I'll just use colors. Well, when we do log base 10, okay, equals, where the argument, sorry, is 1 over 100, and it has to equal -2. Now, we don't write log base 10 because we know from before, if it's base 10, it's understood to be there, so we're going to write this as log of 1 over 100 equals -2. Okay. All right. Now when we're dealing this next one, our base is e. Here's our argument, and here's our exponent. Well, base e goes with natural log, so I'm just going to say the natural log. E would be there of the argument, which is the square root of e, equals the exponent. Okay. So now we're going to look at the going the other way. We have log forms, we're going to go to exponential forms. Okay, so what is our base? Well, if this is ln, we have e is our base. Okay. This is your exponent because the log always equals the exponent, so this has to be your argument. Okay, so we have a base of e. Okay. The exponent is n, which equals our argument of q. Okay, so one thing nice about here's our base of 25. Go there. Exponent is right here, so it's raised to the 1/2. And then our argument is 5, so that has to equal 5. And just remember that 25 1/2 is the same as square root of 25, which equals 5. So that makes a true statement. All right. Now, based on what we did earlier, this base here, looking at this problem right here, our base is 10. We don't see it, it's understood to be 10. Our exponent is 2. Well, 10 squared has to equal 100, which is our argument, which is true. Okay. So note, common logarithms, if you have a log, and it looks like this with an m, remember that's an understood base of 10. If we had ln of m, again, remember the understood base is e. So we don't see the 10 here, don't see an e here, so we need to make sure that we understood what's supposed to be there. Okay, so here is the last page of our notes for 5.1. So what we're going to do is we're going to evaluate logs. And there's some shortcuts or some basic properties of logs that you need to know. So we're going to write those out. So the first thing you want to do is set the it equal to x or y. Some of y'all prefer one or the other, okay? Then you're going to change to exponential form. Okay. You're going to get a common base if needed. Okay. Then you're going to drop the bases, okay? Set exponents equal to each other. Okay. So here's some basic shortcuts, or these are what I call properties that are important for logs, okay? So the first one is that if you have log, okay, base b of 1, that equals 0. Okay, so if I were to change that to exponential form, this is why it's like that, because I would have b, which is my base, my exponent is 0, and I have set to the argument of 1. So anything raised to 0 power is always 1. So if I have the natural log of e, which we understand is just base e, it's still going to be 0. If I have log base 4 of 1, again, it's going to be equal to 0. Okay. Number 2, if you have log base b of b, that's going to equal 1. Okay, so the reason that works is because if you change this to exponential, you have b is your base, the exponent is 1, and it's equal to b. So that is an understood 1 right here, if you think about it. If I follow the rules, then they equal to each other, okay? So log base 2 of 2, so if these two bases are the same, I know I can put a 1 here, okay? This one right here, understood log base 10, so 10 to the 10th, log base 10 of 10, is equal to 1. And that last one, we have natural log of e. Again, this is understood base e, so I have ln of e, which equals 1. Okay, here's another property. Another nice shortcut for us. So if we think of log base b of b to the x, that just equals x. Okay, so if I have log 2, base 2 of x, if these two are the same bases, then I'm just going to be equal to my exponent. Again, here, this is understood base e. If I have a base e and e to the x, then x is just going to be my answer. Okay, number 4. Number 4, if we do base b raised to the log of b to the x, this answer is just x. Okay, so if you look that this base and this base are the same. So here ln e, which it has an e there, so you have e, the ln e of x. Okay, those bases are the same, so therefore my answer is just the argument here. Here base 5 and 5, they're the same, so my answer is just the argument of x. Okay, so now we're going to do these, evaluate these following. We have some examples here. So again, depending on what you like to do, one of the first steps we said up here, and we can pull up here, is set at x equals x or y. And then change the exponential form if you need to, get a common base if needed, and drop base and set exponents equal to each other. Okay, so then now what we can do, if we use that information, even these properties, let's see if we can solve each of these. So evaluate the following. Okay, if you look at this, this base is the same as this base. And so if we look up here at property number 2, we have, if we have log base b of b, that just equals 1. So this answer is just 1. Okay. We have ln of e of 1 over e. Well, this has to be the same base. If I put an e here, great. But 1 over e is not the same base. You can't use it in a fraction form like that. So what we'll need to do is we'll need to change 1 over e, remember, is e to the negative 1. So if I rewrite this as ln of e to the negative 1, then I haven't understood e here with this e. So it's pretty much going up here to number 3. If the bases are the same and you have whatever the exponent is, that's what this answer will be. So this answer is just negative 1. Okay. Here we have log base 2 to the first power. Excuse me, log base 2 of 1. Okay. Again, using our rules, if we go up here, log base 2 of 1, that b is the same as that 2, so that means this has to equal 0. Okay. Now starting with 4, you don't have anything unless they're the same base. So if they're not the same base, I need to change them to make them the same base. That was one of our steps. So I know I can rewrite 49 as 7 squared. So this will be log base 7 of 7 squared. So based on number 3 up here, this answer would be just 2. Okay, so number 5, same as kind of like with the one above, because I have that fraction. I know I have a 49 we know is 7 squared. I mean, I can write 1 over 49 as 1 over 7 squared. And then if I make it to where it is a negative, because I'm going to make it to 7 to the negative 2, again, based on number 3, property number 3, this answer is just negative 2. Now the next one's a little different. We don't know, you cannot change 7 to 49, a base of 49. So what we're going to do is we're going to have to change this to exponential form, like it says up in our notes. So we're going to set it, pretty much changing to set it equal to y or x, exponential form, common base, and then set the exponents equal to each other. So let's do that. So we're going to change this to exponential form. I'm going to set it equal to x, and then I'm going to change this to exponential form. So here my base is 49, my exponent is x, and that has to equal my argument, which is 7. So changing from exponential form will help us to solve for it. Okay, so now what we do is if we change it to the same base, like it says, then we can set the exponents equal to each other. Well, 49 is the same as 7 squared. So I have 7 squared, 2x equals, and this is 7 to the first power if you think about it, okay? 7 to the first power. So here now I'm just going to drop the bases and set the exponents equal to each other. So I get 2x equals 1. So x equals 1/2. And if you think about what they're asking you, they're saying 49 to the 1/2 equals 7, which is true because that's the square root of 49. Okay, next problem. Again, same problem. The base is we cannot change this to something with a 49, but we can rewrite it as log 49 of 7 to the negative 1. And then we're going to set that equal to x. Change the exponential form. So there's your base of 49. Your exponent is x. And it's equal to 7 to the negative 1. Okay. So now I'm going to solve by changing 49 to 7 squared, but times an x, equals 7 to the negative 1. Now the bases are the same. I can set the exponents equal to each other. So 2x equals negative 1, so x equals negative 1/2. All right, next one we want to think about, let's change this to 7 to the 1/2. 7 to the 1/2, sorry about that. Okay, so we're going to change this to log 49 of 7 to the 1/2. We're going to set that equal to x and then solve for x by changing this to exponential form, okay? So we have 49 to the x equals 7 to the 1/2. I'm going to go over this way with it. So that's 7 to the 2x equals 7 to the 1/2, which equals 2x to the 1/2, okay? And then when divide by 2, you're going to x equals 1/4. Remember to multiply both sides by the reciprocal. That's how we get 1/4. Okay, let's look at number 9. We have log base 27 equals 9. Again, those are not two bases that can be compatible like this. So we're going to say I'm going to set it equal to x. I'm going to change the exponential. So 27 is my base. X is my exponent equals the argument of 9. Then change these to common base of 3 between 27 and 9. The common base equals 3. So this is 3 cubed times x and then 3 squared. Set those equal to each other. The exponents equal to each other. 3x equals 2. X equals 2/3. Try number 10 and check your answer back in a second. Okay, for number 10, again, set equal to x. I got a common base of 3. I changed it to exponential form. So 27 is the base raised to the exponent. X equals the argument of 81. Changed both of those to common base of 3 and got x equals 4/3. Okay, so number 11, we have 8 and 32. So we need to change those to the same bases, but you can't do it like this way. So we're going to set this equal to x. We're going to change it to exponential. The base is 8. Exponent is x. It has to equal 32. Now this common base is 2. Okay, so 2 cubed. 8 is 2 cubed. And then 32 is actually 2 to the 5th. 2 to the 4th is 16. So 3x equals 5. Because I set the exponents equal to each other, drop our bases, and then solve for x, and I get 5/3. Okay, last one, number 12. Here I have to change this to exponential and then kind of find our common base here. All right, so if I set this equal to x, is 0.01 to the x equals 1,000. And I should pronounce that the right. So it's 100th to the x equals 1,000. So now we got to find the same base. So we need to change this and get out of the decimals. So this is going to be 100th raised to the x has to equal 1,000. And we're looking at these right here, the hundred and thousands. We got a common base of 10. Okay, so this is 1/10 squared to the x equals 10 cubed. But then this is a fraction, so we're going to make it not a fraction and get a negative 2 times x to 10 thirds, and then set those exponents equal to each other. Negative 2x equals 3, x equals negative 3 halves.